How you doing, guys? Thanks for stopping by. Going to give you a quick tutorial on how to use the Testo 410-1. Great professional pocket tool for testing various ventilation systems. So that could be HRUs, HRVs, HVACs, general just normal ventilations, extractor fans, and whatever it may be that has a ventilation duct. So let me get on and turn on this extractor. So this is quite a good machine. It's got good aluminium on it and stuff. Shows durability. But turn on the machine. You just want to turn on the machine. It measures in Celsius and Fahrenheit, so you can change those numbers. We change numbers, letters. We want to test in Celsius and in meters per second. So just on a general one, we can get a general calculation just by holding the device in one area, but I don't really recommend this. I recommend getting an average because the duct actually can let off different variations at different points. So you could hold it down the bottom here. You've got 0.3 there. Over here you got 3.1, 3.2. Over here 2.8. You get the gist of it. So let's move on to determine the average. So how you determine the average, you press mode again, press mode again, press mode again. When you reach to this part, you actually hold mode, you come off of hold, and then you just go on to your extractor and you hold it till it reaches the peak. It looks like the peak here is 2.7. Then you move over 2.7, 3.2, 3.1, 3.2. You get the gist of how we're going to get this average, because we're getting multiple readings on this 100mm duct extractor, I should say. And then when we come off, we literally press that button, mode again, mode, that's our average. Our average is 2.4, which is a marvelous extraction reading. Very good. Couldn't ask for a better reading. You want to use a calculation depending on the size of your extractor. So there is different readings. I will put a picture. We are using a 100mm duct, so the calculations we need for that will be 0.00785. So our meter is showing us 2.4. We're going to times that by 0.00785, and then we're going to times that by 1,000, and that's going to give us our liter per second, which is getting extracted at 18. It's very good. Approved document F in terms of ventilation states that a room needs to be extracting at a minimum of 15 liters per second. So we've got 18 on this reading, which is above average. So in terms of the velocity, this passes, and no work needs to be done. It's extracting. If you do have any damp mold or condensation, it's probably something else that you need to look into. If you want to determine the cubic feet per minute, we would need to use the liter per second, which was 19. If we want to do a quick calculation, we can just use 2.1189, and that gives us 40 cubic feet per minute are being extracted. And then if we now want to go on to a calculation of meters, because we want to put the size of our extractor into the equation, we're going to use 2.4, which was our meter per second. That was our average, and then the size of the duct has to be put in. In this instance, it's 100mm, so we need to use 0.00785, and then we are going to times, and put our CFM code in, which will be 2118.88, and that gives us a more detailed reading of 39 cubic feet per minute. So that's how to determine your cubic feet per minute, your meters per second, your liters per second, and all of the rest of it. You can actually go total buffing mode, and you can go to FPM, which means flashes per minute, and flashes per minute determine how many rotations the propeller is doing. So if you want to be a total nerd, you can give that reading as well. Sorry, I've just put it on hold, because you can do the same average as well, guys. You can do the same average with the same method of going around the extractor and then determining the average of the spins. And I do hope this helps. If you need any more guidance on this, hit me up in the comments.